All right, section 3 of chapter 20. Talk about groundwater a little bit first. So groundwater. U.S. population, 95% of people who live in rural areas get all their water out of the ground. So you guys well know if you live out of town, you must likely have a well. So it's pretty important, especially in rural areas, to keep groundwater from getting polluted or having problems because it is a drinking source. And generally speaking, half the U.S. population uses groundwater, both from a municipal point of view and or a private well point of view. So groundwater is really important to underlying our water issues. And so what are some common pollutants of groundwater? Gasoline, fertilizer, pesticide, and organic solvents are the big four. And where do those come from? They come from spills, leaky pipes and tanks, and then it can seep down into the ground. And so these are the big issues that we face with groundwater. And the problem with groundwater is it doesn't clean itself very easily at all. So once a pollutant enters the groundwater, and groundwater is basically stored in these little porous areas in between rocks underground. And so depending on what kind of rock you have, you might have more space or less space. And so the amount of groundwater varies. Ability to get a certain amount, how many gallons up per minute, all that kind of stuff varies based on the size of these pores and how permeable they are. But when that leak gets in there, let's say it's oil, gets in here, it then grabs a hold and coats the sides of these rocks. And it clings in there. And as a result, it kind of gets absorbed like a sponge, just like the water does in there. And it's really, really hard to get that contamination out once it's in there. So removal and cleanup is extremely expensive, costly, and in some cases, some might argue impossible. And so not polluting those really makes a big difference. Here are some major sources of pollutants. So mining, surface mining creates a lot of problems. Some people don't think about this, but de-icing road salts. They run off into the groundwater and can create some problems. You might have a waste lagoon, or there's your accidental spills. We pump and or inject hazardous waste underground. That can create problems. We can have leaks from tanks. We can have raw sewage from cities that get in it. We can get landfill leakage, pesticides and fertilizers. So there's lots of different places that it can infiltrate into the ground. Once it gets in there, so this is a city view, once it gets underground, that pollutant then will spread out, and it will spread out in what they call a plume. And so a plume is that specific shape or form that it takes. Groundwater isn't stationary, it flows. It just flows really, really slowly. So once you have your leak, say this underground tank right here, as it leaks and the water's flowing or moving, it pulls it along and it spreads it out as it pulls it. So this is a case where this underground water supply is actually bleeding into a freshwater lake or stream. Other times it can stay underground and just spread in through houses where there might be wells or pumps and have access to it there. I used to teach in Colorado, and Colorado had a lot of feedlots right where I was at. Three of the largest feedlots in the world were actually in Yuma County where I actually taught. And we used to test the water east of town where those were at. Anybody that lived east of town for the most part had nitrates. They had nitrates in their water, and it was a simple idea that it would leak down from the feedlots, get in there, and then work its way through that underground stream to those people's houses. And so more common problem than we think, and it results in lots of issues. I remember when I was a kid, my dad, we used to change oil, in the vehicles, and we had a telephone pole in our yard, bottoms coated in that black stuff, and buried underground, and we were on a well, and I remember every time we'd change oil, my dad would say, go just pour that oil, that oil that we changed out, all that dirty oil, just go pour it next to that pole out there. It's already got all that stuff on it, so it won't hurt anything. And we were pushing all that stuff right down. Our well water was not very deep at all, and I can just imagine how many gallons of oil I drank in my life. So, groundwater. It's not cleaned very easily at all, as I mentioned earlier. Lots of different chemicals, lots of different issues. There's not an opportunity to really dilute it or disperse it very much because of really slow flowing movements underground. So if it's concentrated in an area, it'll stay that way. There's not very much dissolved oxygen underground, so it can't be decomposed down there very easily. There's not as many bacteria present in that water as there is in, say, surface water. And so there's not as much stuff to break it down, even if there was oxygen present. And then the temperatures down there are colder, which slows all the chemical reactions down. So for all these reasons, it's really hard to clean it up. And so As a result, a contamination can last hundreds to thousands of years once it's happened, and so that's a real problem, especially if you have non-degradable wastes, things that don't break down in nature, like lead or arsenic or fluoride. All of those things basically create permanent problems underground for us, and that's a real issue. So this is one of the few times where you really can't think of this issue as how do we clean it up best. It really needs to be a situation where prevention is the only real solution. And so prevention can happen lots of ways. You can find substitutes for toxic chemicals. You can keep toxic chemicals out of those parts of the environment. You can install monitoring systems around underground tanks. You could require leak detectors on those tanks as well. You could ban hazardous waste disposal, either in landfills or injectable wells where it can get access to it. And then you can store harmful liquids in above ground tanks where you can detect the leaks right away. So these are all ways to prevent the problems. After it gets underground, what are your solutions? Well, cleaning it up, and none of those are very good choices. They're all time-consuming and expensive, and they don't all work well, and you'll find that a lot of them don't even necessarily exist yet. So you can pump all that water up to the surface, you can clean it, and then you can squirt it back into the aquifer. Extremely expensive process. You can inject microorganisms down there to help clean it up. Not as expensive, but it's still pretty costly, and it takes a long time, if at all, if they can move around enough down there to really solve your problem. And then the newest thing you can do is pump nanotechnology, nanoparticles of inorganic compounds in there to remove the pollutants. This is still being developed, so it doesn't even exist yet. Next, well, how do we go ahead and take care of purifying drinking water? Well, we use centralized water treatment plants for a whole shed, and that can help protect things, and it provides us safe drinking water for cities in developed countries. This is how we do it. We have one big centralized water treatment plant for Buffalo that cleans our water and takes care of it for us. Most of you have been there. There's other ways. There's simpler ways. There's cheaper ways to do it than that, to purify water, and we can use those techniques in developing countries. For instance, they can boil the water, or they can expose it to UV light for 3 hours and kill microbes. That's going to take care of the biological issues. It will not take care of toxins and chemicals and things of those nature. So this is to help it become drinkable from a biological point of view, but it doesn't solve all those other problems. So, well, most developed countries have drinking water quality standards and laws. Most of the developing countries don't. And until that happens, until they have standards that they meet, are required to meet, this probably will be a continuing problem. In the United States, that law is the U.S. Safe Drinking Water Act. And it basically tells the EPA that they need to have some standards. What is the maximum amount of nasty stuff we can have in our water before it's consumable? So there's limits. It doesn't have to be free of everything, but it has to have small enough quantities that it's not toxic for human health or have adverse effects on human health. Originally this focused on just water treatment plants, but now it includes the protection of drinking water sources as a whole, lakes, rivers, streams, and groundwater. And so the law's expanded over the years a little bit, but it is why there are requirements in place. It's what our water treatment plant in Buffalo has to utilize. They have to follow these guidelines. More things on laws with this. So the UN estimates that even though those laws are in place, 5.6 million Americans still drink water that doesn't fit those standards. That means 1 in 5 Americans drink water from a treatment plant that actually violates the standards. So of these, there's a lot of them that are drinking from wells or something like that that aren't meeting the standards. But in addition, 1 out of 5, 20% of people who are drinking from a city source, the city source isn't following the rules. And so that's still something we definitely need to work on here in the United States. There has been pressure put on by industry, of course, to weaken that act a little bit because it's very expensive to make sure all the water is cleaned up to those levels. So they've done that through the elimination of national tests and public notifications of violations. They've allowed rights to pollute if the provider cannot afford to comply. So If you can't afford, you can go ahead and not clean. And so that's an issue. And then of course, they've stripped down the budget a little bit in those areas as well. So these are all things that have made it a little bit harder to enforce this law in the United States. Let's move on to some drinking water out of bottled water. So bottled water, is it the answer? I would say in short, no. First of all, a lot of things you don't know about drinking water. I'm going to give you a document to read in class. But about a quarter of all bottled water is just regular tap water. So there's no difference between it and what you fill out of the tap other than the price is about 200 times more expensive. 40% of bottled water is actually a lower quality than the tap water, yet it costs much more. So we're making this assumption because it's bottled water, it must be good. In many cases, especially in Buffalo, where our tap water is really great, bottled water just doesn't meet many of those same requirements as tap water, and so that's sad. And then in addition, bottled water, to make the plastic bottles, you need fossil fuels, you need oil. And so in order to produce those plastic bottles for the United States, we could have fueled 100,000 cars with that same amount of oil. And then afterwards, we're making 1.4 million metric tons of plastic bottles have been thrown away. And here's a picture in the background of just how many that is. So bottled water, even though convenient, has a lot of downfalls to it.